So this is lesson 8.4 in intermediate algebra. It has to do with function notation. And what we're going to do here is just get you familiar with the whole idea of functions. And they're really not that scary. For the most part, what we're doing is we are not going to be writing the letter Y anymore. We're going to be using something else. That is the main difference that we're looking at here. Alright, so when I give you an x value and I say, given this problem, find y. What you do is you put your 3 in there for x, and you get 6. 2 times 3 is 6, 6 plus 6 is 12, and that equals your y. So when you put 3 in, you get 12 for your y value. So you get an x value of 3 and a y value of 12. Alright, what we're going to do is just kind of explain what's going on here a little bit better. I know you've been doing these for years and you're like, what the heck, I need an explanation of this. Yeah, you kind of do. So when I have my 3x plus 4, and we're going to put the y value over here, that's one of the things that we're going to do different, is we're going to put the letter that's isolated on the left hand side and solve for y, but we can't solve for y unless we're given an x. And every time we put in a number for x, we're going to get a different number for y that relates to it. So for example, if I put a 0 in for x, I'm going to get 3 times 0 is 0, plus 4 is 4. If I put a 1 in for x, I get 3 times 1 is 3, plus 4 is 7. If I put 2 in for x, 3 times 2 is 6, plus 4 is 10. So these are my x values, and these are my y values. Alright, so instead of using the y right there, we are going to use something else, and it looks like this. And that is, you say that as f of x, f of x. And what that means is, what is my number I get, what is the number I get as an answer when I put 0 in for x? Okay, so what this means is, what y value do I get when I put a 0 in for x, a 1 in for x, or a 2 in for x? So what I'm going to do is I'm going to rewrite this equation here as f of x equals 3x plus 4. Not real hard. We're just replacing the y with the f of x. Alright, so what that means is, if I write this, that means, what number am I going to get when I put 0 in for x? And I'm going to get 4. So I'm getting the same answer. It's just writing a little bit different. This is telling me what my x value is that I'm going to plug in here. So instead of doing this here with this column, I might write f of 1. Well, f of 1 is going to be 7, because when I put 1 in there for x, I get 3 times 1 is 3, plus 4 is 7. If I put f of negative 2 in there, I get 3 times, I'm putting negative 2 in for my x, so negative 6 plus 4 equals negative 2. So when I put negative 2 in for x, I get negative 2 out for an answer. So when you look at example 1, it gives you a bunch of different options there for your function. It tells you that your function is f of x equals 7.5x, and it says find f of 0. That means you're going to put 0 in for that and multiply it by 7.5 and get 0. It says put 10 in, f of 10, and you're going to get 7.5 times 10, which is going to equal 75. It says put f of 20 in, and you get 7.5 times 20, and you will get 150. Okay, so all you're doing is being told what number goes in for the x here, and then your f of 20 then equals the answer here once you plug it in. Now, the only thing that gets a little bit different is, instead of a y, we're going to put an f of x. But it doesn't have to necessarily be an f of x. Sometimes they're going to give you a g of x or an h of x. It doesn't matter what letter this is. It's still looking for the y, or the number you get when you put a number in for x. So if I put f of x equals 2x plus 3, and I tell you that my f of 1, that's going to be 2 times 1 plus 3, and that's going to give me 5. So f of 1 is 5. If I do the same thing with g of 1, and let's say I have my equation, instead of f of x, I'm going to put g of x, 2x plus 3. G of 1 means I'm going to put 1 in for x. I get the same answer, so g of 1 equals 5. So the g, the h, the f, it doesn't really matter what letter you're doing. Usually they'll do two different letters when they're giving you two different equations, and they want to make sure you don't get confused and mix up, your answers and stuff there. But for the most part, that's what we're looking at there. So let's jump to example number 2 here. I haven't even looked at it. If it takes Lorena t minutes to run a mile, then her average speed s of t in miles per hour is given by the formula. Okay, so it takes her t minutes to run a mile. Her average speed, what is speed? Distance equals RT, or speed equals distance over t, right? Miles per hour or whatever. Alright, so what they're saying is, if her average speed, s of t, which this means speed given a certain amount of what? Minutes. T minutes. T represents one of the variables, which is how many minutes it takes. S of t means if we're given a certain amount of time, if we put whatever number this represents in here, then we're going to get her speed. So you really don't even need to know what this means. All you need to know is that this is a variable, just like t is a variable. All right? So, her average speed, s of t in miles per hour, is given by the formula. All right, so distance, like I'd said a minute ago, distance equals RT, or R, which is speed, equals distance over, okay? That's speed. And what they're saying is, in this, the given formula, s of t equals 60 over t. Okay, that's what this formula is, and they just kind of transformed it into something with the s and t that looks like to confuse you. But they give you the formula. That's the function. That's what's in the function machine. We're going to put a number in here for t in order to find speed. Alright, so let's say they want to know s of 10. What is s of 10? S of 10 is, t is related to what? Minutes. So the speed in 10 minutes, s of t, equals 60 over, and we plug that number in for the variable. Alright, if we're interested in s of 8, that equals 60 over 8. We're just plugging the number in the parentheses in for the variable. Okay? So, if it takes her 8 minutes to run, she must be running 7.5 miles an hour. If it takes her 10 minutes to go, it's going to mean she's going 6 miles an hour. Alright, let's look at example 3. A painting is purchased as an investment for $125. Okay, so that's how much it cost. If its value increases continuously so that it doubles every 5 years, then its value is given by the function. So we don't care about all that stuff. All we care about is the formula they give us. And that is 2 to the t over 5 power. There's the formula. You don't have to understand where it came from or anything else at this point. All right, t is the number of years since the painting was purchased, and Vt is its value at some particular time. So t is how many years has gone by since the painting was purchased. So let's say the painting was purchased in 1980. Well, t then would be, well, it's 2017, so that's been 37 years since it was purchased. Okay, so that's what the t would be, is how many years has gone by since the painting was purchased. Vt, what I have here, V of t, is its value at that time, because the painting gets more and more valuable as time goes on. So V is value over a certain amount of time. So the painting in 1980, when it was purchased for $125, maybe in 1990, 10 years later, it's worth $200. And then say in the year 2000, which is 20 years later, let's say it's worth $400. I mean, it just keeps getting more and more valuable as time goes on. All right, so let's say, using this formula right here, let's say that we are interested in how valuable that painting is going to be in 5 years. Okay, so that is going to equal 125 times 2, and we're going to replace that t with 5 to the 5 over 5, which this is 1, right? Any number over itself is 1. So that is 125 times 2 to the first power, or just 2. So in 5 years, it's going to be worth $250. All right, let's look and see what it's going to be worth in 10 years. I'm just going to put 125 times 2, and I'm going to put a 10 over 5, and that is 125, and that's to the second power. So 125 times 4, which means in 10 years it's going to be worth $500. And that's what they were interested in. Taking the number of years, plugging it in the equation here, and then we did it again here, and finding out what the answer is based on what number we put in for our variable up here. And we put a 5 there, and down here we put a 10 in place of our t there. And that's it. Alright, so I'm going to continue on with example 4, 5, 6, 7, and 8 in the next video. So this is it for 8.4a.